Hi, I'm Ann Groff, manager of the Analytics Department here at NuSil Technology. Today we're going to talk about elastic modulus, which is commonly referred to as just modulus. It's a physical property that's measured on cured material, and it's key to helping you choose the right NuSil silicone for your application. The design engineer needs to understand the forces the silicone will undergo during its normal life. Will it need to be flexible and stretch like a balloon? Or will it need to be inflexible like a hockey puck? What we're really doing is considering how the material will change in form. Modulus is an object's resistance to that change in form. Since a balloon can change form easily, we would say it has low modulus. And since it takes a lot of force to change form of a hockey puck, we would say it has high modulus. How do we quantify modulus? This brings us back to tensile and elongation. We plot modulus on a graph. On the y-axis is tensile. Tensile relates to the strength of a material, or the amount of force required to stress it. On the x-axis is elongation. Elongation relates to how much a material will stretch, or its strain. Modulus is the relationship between that stress and strain. The data that we use to plot modulus is from our MTS testing, and modulus is the slope of the stress-strain curve. A line of low slope represents a material of low modulus, like our balloon. A line of high slope represents a material of high modulus, like our hockey puck. Now let's take a look at some products made from our NuSil silicones. This is a prosthetic sleeve, which delivers comfort and protection to an amputee between the skin and the prosthetic. It needs to fit to the body or change form easily, so it has low modulus. Again, take a look at our graph. The silicone used to make this prosthetic sleeve has a relatively low slope in the stress-strain curve, so the material is of relatively low modulus and will be flexible. Now let's take a look at some medical grade tubing. The tubing needs to hold its form to consistently deliver fluid to patients, so it will need a material of relatively high modulus. Again, let's take a look at our graph. The silicone used to produce this medical grade tubing has a relatively high slope in the stress-strain curve and will have a relatively high modulus to make the tubing strong but slightly flexible. When choosing a silicone for a particular device, there are many things to take into consideration. People often confuse durometer with modulus, but these three curves clearly show that material of the same durometer can have a significantly different modulus profile. And since what you care about is the flexibility of a material all at the same hardness, you should base your material choice on how easily you need the silicone to change form, which is modulus. Thank you for joining us today to learn about NuSil and modulus. Again, we have the sophisticated instrumentation and the technical expertise to help you choose the right NuSil silicone for your application.